Well, this is the second year we did with these lunch talks under the logo of Innovate, and I think in this case we have a special guest because he is not directly an architect, he belongs to the other side of the innovation, which has a business that he inherited from his family in relationship with concrete, and he has developed a graduation in business university in Vienna, Wolfgang Rieder, and he has become a very important part of the innovation in concrete this last decade, dealing with very smart new innovative solutions, working with important architects and working with people like Matthias Schuller, that mostly all of you, or many of you know, because he's teaching frequently in this school. He also, one part of his work is made in collaboration with other universities, especially with the AA, and we now want to have him involved. He's been involved in these learning together with Spera and Rock are dealing with, and we hope that we will have him more times involved in issues with us. So join me in giving him welcome. And you know the format is very simple. We try to maintain it in 20-25, maybe 30 minutes as a maximum intervention. Then there is a response that will be given by some instructors like Salman, Spela, and Rock, and some students or people that have been students. In this case, will be Colin Garner, that is a research associate that is precisely helping us to create the Harvard Symposia on Architecture this 30th of October, the first symposium on design techniques is dealing with all the research. So that's it. Thank you. Please.
I'm so nervous I forgot my Hello everybody, so thank you for attending my lecture, so I will be on time, so 20 minutes. Thank you for your kind introduction, Inaki and Spella, for pushing me to come here. So, my talk is basically about concrete and innovation, which is an obstacle in itself, I think, but I think we've done our best to come up with some new ideas, which we really think. So this is one of my favorite pictures. Some of you may know it. It's Ulrich Lüther. It's a Eastern German Baumeister, and in the early 50s, because out of scarcity, he made these nice little structures. So I'm talking about concrete. I think everybody in this room knows the way we have a special way in manufacturing it. We call it extrusion, which was a technology which I bought some 10 years ago, which was about to be demolished by the Frenchmen, which is also a miracle in itself. And so we saved it from that, and so our main purpose at the moment is facades with traditional scaffolding and lots of hard Austrian labor. So in a nutshell, what we do is facades, and with our thin panels like this one. And I just quickly take you through, and the point I'm going to make there is I was so surprised that there was such a positive reaction on our product. And I always thought, why is that? So isn't there anything special on our product? Is it just the product, or is it maybe the owner? But my kids never said, no, it can't be you. And so when we look at this and as Inaki said, I'm a bloody businessman by profession, and I'd love to study design or architecture, which I never did. But so I just closely followed the architecture and the architects and their works. And I always wonder, to look at it, and you can look at such building on several perspectives. And one could be, the business guys look at it, how much margin they get out of the square meterage. As an architect, you have a different perspective, which I don't need to explain in this room. But as a manufacturer, I look at the opportunity to sell panels. On the other hand, now I've been, as Inaki said, involved in other trades like the whole thermal and energy and lead environment. I look at this glass building and I say, oh my God, I could never work like this in the middle building. So it's nice to have a good view onto the river in Cologne, but thermally it must be a nightmare to work there. So going back a little to see how we evolved. So this was one of my first projects with SaaS, and we went into this customization thing. So bluntly and unexperienced. So this was our first project in Spain. So this was Zaragoza, 29,000 triangles. Yeah. Yeah, and I was not really into this 3D thing, and so I said, yeah, we're gonna do it. So, and we did it, and then Saar came and said, okay, they insist on 9 different grades of gray. He said, there's hardly any scale out there measuring the different grades of gray. So we came up with one. And the 29,000 triangles we did into an Excel sheet out of the Rhino drawing, and so we did it all by hand, and we ended up in a logistic nightmare, which didn't really pay back well. And so, but we succeed, and so we've gone to the next step, which was this building in South Africa, and for the last World Cup, as you may know, and there, the interesting thing there was that we've been not only delivering the panels, but we also installing them. But this was more like an accident because we had a German partner who just keep on talking and not working. So I stepped in because there was the World Cup and this was hardly to postpone. And if I be blamed for this, this would be probably the end of my career. And so what we did there is, in business ways, remarkable, we beat the Chinese on price. Not because that I made a huge discount on my panels, but more or less we integrated the substructure and the whole planning in an early stage. Because of the South African also that they're blamed and punished in the media for not finishing the World Cup on time. I mean, they did it 6 months ahead, and they're letting even a small Austrian guy out of the mountains doing their major stadium, which is 10,000 kilometers away. And I found that quite brave. So I really pushed hard to do this project and finish it, which we did. And the way we beat the Chinese aluminum was that we made a modulars, and we had a field fabric on site, and we assembled on site. So it was a combination of off-site engineering and on-site assembly, which really worked out well. And so this is also one thing which, when I look at it, is one of the latest Saar building. It's a campus in Vienna. If you see this kind of louver things, so this led me to two things. First, we innovated a new product. We call it now fins, or this louver thing, because we bend and fold the concrete, which I'll show you later. And we arrived and found out that there's some new material characteristics which we never knew before. I should have probably listened more to my physics in school and structural engineers, which I usually never listen. So, and this is the third one, is that we can really play with the surface. Like this one was a booth in Switzerland where we simply inserted during the curing these discs, and so it made these wrinkles, and while it cured, so it stayed. So this is another booth which we did. So this is more like everything is quite nice, you know, I can make my living. But I think, you know, to be an innovator, I think it's not enough by far, you know. I'd be always surprised going into architect's office and say, hey, I have a new color. And the architect say, cool. So, or I come and say, look, I have a new surface. And I said, what are you going to do? You know, I sandblast. So, and I said, come on, I mean, to sandblast, this can't be new, this can't be called innovative in a way, so it really doesn't add any value. And I was surprised that the architects are not more critic with me, you know, when I show up and say, hey, I got the new color for you. So I said to myself, you know, I need to go back to school, and like what we do, this lovely pavilion tradition, like we did this one at the AA, together with Hanif, which is also a faculty member, and even Saha showed up one day there. So the whole group of students built that, and it was a classical Saha building, so 4 times the budget. And so the pavilions are really nice, and I really stick to that idea. So this was really our early days. So what we also learned is the seamlessness. So this was this could be a Chinese project, which is also a SAR. What we ended up is that we had a Chinese espionage effort. So my travel to China is now limited because we put the guy in jail, and they said they usually take revenge. So I don't want to end up there. But it was really fun on the one hand because it gives me really nice airtime in Germany. Every time when they talk about industry espionage, I'd be called up, and I'm sitting next to the real James Bonds there. That they aren't that good looking, but they're really powerful guys. And so I get some free airtime to tell my story. That you know. And the other thing is that it looks like that we're really having some know-how which are that they are interested. And this is also, I think, in a way remarkable for me that the Chinese are always, you know, the Europeans are quite quick to point the finger to everybody, says, okay, they copy and paste. And I say, yeah, what else could you do with innovate, you know, to copy, to look at things and then to do it better. I mean, for me, this is quite, you know, the inner mechanics of innovation is that you look at other things which are on the market and try to make it better. So I don't blame anybody for this. So geometry control, we also went there, like with this one, which we also did with SAR, and they made me move to all these very special countries, like this was in Azerbaijan, which wasn't done by us, but what we have done there is 7th generation of mock-ups, and on my expense. And this is a curvature which I did, so these are, you know, the costs, and usually, and this is showing my motivation. And usually I say my motivation was after the 3rd generation of the mock-up, it was like at the very bottom. And the reason was that we didn't succeed was that nor Sarah was happy, nor I was happy that we tried to kind of 3D bend our panels. And we had to overcome the foil issue and the wrinkles and many other things. And then Sarah came and said she doesn't like this surface doesn't match this one. And I explained, you know, when you cut, then it's a different surface. But this was not good enough. But so anyhow, so what I think is also a principle in innovation is that you keep on pushing. And I have this, you know, this Samuel Beckett thing everybody is probably tired of, but to fail and to fail better, this is really something which I think is also one of the key principles of innovation, that you don't give up. And so for us in this one, we came across many other things. And so I've just thought yesterday about what's really, you know, on my agenda and what I really want to pursue after gone through all of this. And one thing for sure is that, you know, as I said, concrete is a very well-known material, and as I've been Austrian and I've been with Syndicon, the German big brother to the north, but they are really good in one thing, in testing and writing codes. So 90% of the industrial standards in the world on concrete is coming out of Germany. So having a concrete like mines, so this is everything out of code. So when I approach them, they say, out of code. And I said, and so how can I get it to the market? Yeah, they don't know because there is no code which we can test it against it. So I think this was at the beginning quite an obstacle for me, that beyond these codes there is really something new. And new to me is that we push these flat sheets into certain geometries, and by doing that we found out that they're getting much more rigid, much stiffer than they are. Like this one we did in Prague, and all these white stripes, so the verticals, so that the horizontals hanging on the verticals, so they're only fixed on 2 points. So it's really very fast, monolithic, and even the glass guy could do it with the same tools he's lifting the glass into place. So Prague was really a hotspot. We did 3 buildings there. This is another one where we put the L shape, but in doing that we found out that we can really like this one really help to bring architecture to life. Like this drawing shows a rectangular glass building underneath and a 3-dimensional mesh. And the way we approaching this is that we dividing this diagram into, we call it diamonds, like this one, and they are all L-shaped panels. So at the end, we're ending up then having also lots of L-shape with certain cuts where we get the information directly out of the Rhino and put it onto the machine. So we can really reduce the weight and really increase the performance. Like this one, I'd like to make a video, but didn't work out. But there you see, with the additional of a honeycomb, we ending up to really bend the concrete without any wrinkles and without any cracks, which is also not possible according to the German code. But it's, that's why it's always so impressive to put the dead load of 6 guys onto it, and it really flexes back, and it's the same thing. And so given that, so I think one of the thing is also, which is I think the third imperative how we work, is we try it out. We don't push it, we just do mock-ups, to find out and to see where it will take us. And the other thing is that you said that we integrate, or that we find out by doing this, that we integrate some other intelligence. So we have the sun, and if we always refer to the skin as a metaphor for the building and envelope, and if you look at a human body, how much more intelligent our skin is than we build in the 21st century houses. All things which we have is an opening, like a window, and then non-visible things. Now we have the greatest inventions of louvers, not letting sun in, and then we pump into the buildings lots of air conditioning. But if you compare this to our human skin, so same temperature, plus minus 1 degree, so our body doesn't think in heating nor in cooling, so it has a permanent, it is a wrap, it has other sins, so it's so much more intelligent. But we thought, why don't we take the veins, or a metaphor, so we did capillary tubes into our thingy, and this is where we got involved with Matthias, and we tried it out, because this is a technology which is used in cooling ceilings inside for many, many years, and we basically mixed it. And this is the house, so you don't see it. This is a big obstacle for me, because I had an internal statistic done. When I gone to architect's office, I always ask them the difference between solar thermal and photovoltaic. And on this question, usually 60% fail. So they explain me, yeah, it has something to do with electricity and with the heat, and I agree. So this is the most favorable answers. The other ones I don't give you back. In all fairness, I didn't know it either. But so what we're seeing there, me as a manufacturer selling solution to a person who doesn't understand, and me barely understand it either, we should probably talk about something different, you know, because otherwise we're never ending up to creating something valuable. So this was one of the hardest selling, even in my company, you know, that my guys really opposed me and said he's now going totally nuts. So we either keep him in academia or they should do something. But I'll show you this house, which is a retrofit, and the little green dot on the far left, maybe the COP, so it says how much energy I pump in, so this is 1, and how much do I get out. So all these heat exchangers are usually at 1 to 3, 1 to 4, and we are 1 to 13. And then my tech friends showed up, you know, the guy from Fissmann, so this heat exchanger, and they took out the controlling unit. This is not going to work, so they put in a new one, they calibrated, so 1 to 13. So then they said, no, we need to erase the data, start from the scratch. So 1 year after, 1 to 13. So we're still there, so we have now an open link, an internet source, and now as Matthias is checking it, so I'd be quite confident that this is way better than everybody ever experienced it. So we have we have a battery there. It is. So all I'm going to say is that, you know, it took me quite a long time, and especially that I'm competing now with the new iPhone presentation, and I'm so big. But so many, despite this major event, made it here. Is that this pavilion and how to communicate something which is invisible. We came up with this pavilion, so we did this at our 10th anniversary, and we used the color, the blue and the black, and these panels had this capillary system in, and it was rather cold there in March, and they radiate onto you with 30 degrees. And it was really a nice temperature. We did the same thing we did in Venice, and it was at the Biennale, but not at the Biennale. It was a project together with the city of Moscow and Matthias Schuller, and we sneaked in, so we didn't tell anybody that we're doing this, the thermal activated things. So what you see here is the design gang of so these are the Dille Scofiglio guys, right in front, and we had a 10 Celsius cold wall. I don't know if this transfers into this Fahrenheit, but this maybe 40 something Fahrenheit, and there it was 90 Fahrenheit, so 35 Celsius, and it was really a nice breeze radiating onto you. And I thought myself, you know, that, and people really naturally went to the cooling walls, because we didn't tell them that there is something in there, and it really felt that there is an intuition, and that you go there where you feel more comfortable. And I think this is also things which really made me really excited about this technology, that it's really working, yeah? and that we can take it to many other levels, as you see here. So there you see the temperature, and even thermally activated the pots, including that one. And there was one rainy evening, and the one who was heated with 30 degrees gone dry within seconds. So it was really cool, and people just sat on the dry one, which is natural. That's not a good argument for my thing, but so this is for me very exciting, and so what we think is this will take us is that we basically integrate into the outer skin so much more intelligence by adding more stronger and even absorbing the substructure into our panels. the next one would be that we thermally activate it by sending liquid through. And I had in my own company a thing that we have just an office extension. I said, okay, we're gonna try that out, and then I had all my employees opposing my idea, and so we were a bit late. So I said, then what we're gonna do is now, because they said now it's not working, the piping. So we came up with the idea that we ripped out of a car seat the heating of the seat, which is a 12 volt, and we have some PV panels and a battery, and we connect them. So we have a free heating basically on copper wires. So I think this is also one thing that, for me at least, you know, if you do certain things, which usually they say 9 out of 10 innovation fail, so probably this steers you in a total other direction. So you have to be always open-minded. So where this is going to take you, and I told this idea just before I left, and told it to Matthias, and he was not really happy, because he said, you know, this all the waste of it, there's so much better uses for electricity, but maybe for certain things that we can get use of the PV. So the other thing which the whole research on this one led us is that we can, so this is a usual wall with the insulation with our panels. So we were so focused on this generating energy or harvesting energy from the sun. But what we found out is that we call it the active shield. By taking away like a curtain on the south face, taking away the heat, it doesn't penetrate the building and doesn't go into the building. So the calculation as it shows now says that we can cut down the cooling load of larger building by 2/3. And this is really the impact. It's nice to have some additional sun-powered energy, but even more we can, by an integrated planning, so to say, and adapting to the solar and to the sun, we can save 2/3 of the cooling load. And I think this easily translates in saving per square meters. So for the business guys, it easily, and even more and even better, I think for the human being working or living in that building or in that space, really translate into better conditions and more things. So this is where we stand now. So I think it's still a journey with an open end. I'd be glad that I survived all my adventures so far. And as I'm getting older, I'm getting a little bit smarter, so I don't burn my fingers too much often, but I'm still into that I want to carry on and try things out. Okay, thank you for your attention.
We now have this kind of responses by our experts. Spela, please. Thank you. Yes. You can stay here or you can sit down.
Yeah.
I think you have to stay here.
Okay. Wherever.
I'm the only one that is in any kind of position.
Should I start?
Yeah, please start.
Thank you so much for that. What came across most for me is that how much you enjoy your job. I'd actually like to kick things off, not about design or manufacture. I have a few questions about those, but I would like to know more about the espionage. You hinted at it, but it sounded really interesting. I'm very fascinated about the supply chain and how it's reorganizing itself in the East versus the West.
Yeah. Espionage.
Yeah.
So I got the phone call. There's a guy called Mr. Ma waiting for me. I said, do we have an appointment? No, but he's waiting for me. So I said, yeah. So sorry, I've been busy. So, but, you know, I've been not the kind of a superstar that So I really get the bad feeling. So I said, yeah, where do we meet? Yeah, we meet at the coffee place. I went to the coffee place and he gave me 4 gifts for my kids. I said, yeah, how do you know? Yeah, I've done my research. Yeah. And then he said that we tried to get back in China and he can, with his connection, help us. And I said, yeah, why not? You know? And so the story evolved, and so I let him into my factory. Then I was away. Then he came back, and they were quite strangely dressed, all black suits, and his drivers. It was really like a movie. And at the end of the thing, they had a camera installed on his belt, and he was filming how we fold and making the molds. So he was specifically interested in making the molds, and how we did it. Because I had the other thing was, you know, as I said, the copy and paste. I think it is part of innovation, and I was very strict at the beginning to do not patent my things. So this made some people a bit nervous. You know, they didn't know how we're gonna make it.
Why was what made you decide not to patent it? Was
basically it was too expensive.
Okay.
You know? It's not really fun for me, you know, to write this thing down. So it's
okay, thank you. I have one more question, and I'll pass it on. A lot of on the combination as innovation. A lot of the innovation where you're taking it seems to include other materials, and several sometimes. Is it providing you a question where you're moving away from your core business? How do you rationalize that? Do you combine with other suppliers, or is it taking you away from your main business, which is concrete?
Yeah, I mean, I got this question from my banker the first 4 years, and said, you're losing attention. You know, why you go to SARS and all these crazy guys, and they're making mock-ups and sending you back home with big disappointments. And I said, you know, I mean, if we don't interact, you know, the manufacturers, the architecture and design community more, and then I just read a book on my way here to prepare myself for Inaki and then to have the latest academia. So to say, I came across Friar Otto and his colleagues, and what he said really triggered me that, you know, innovation is in his, at least in his, and I share that view, it's really on these interfaces, you know, where you're losing your comfort zone. So I'd be happy to manufacture and do my panels, but does this, you know, really add any progress or really help us as a, you know, as a building industry to get better? And I don't think so. So that's why I think I'd be always losing my comfort zone. Also, that I was during my careers in certain times really on the edge. But I think this on the edge is also a good experience, because then you move faster to the other direction.
Thank you. Sam, what a great person to collaborate with.
Yeah.
I'm interested in asking you something about, I guess, what I call a disposition. You have a very open and experimental disposition when it comes to thinking about concrete.
Yeah.
And it reminds me, or there's a parallel, I think, between certain architects, for example, Tadeo Ando, who talk about concrete as being alive. But I think there's a sense in looking at your work that you think about concrete in a certain way, that it moves towards being alive in a different sense. And that's very clear with your analogy between skin and concrete building envelopes. And I'm wondering if you can say a little about how you imagine concrete and how you sort of think about it in this way that seems almost proto-biological. Is that something that registers for you, or is it something that just sort of happens spontaneously?
Yeah. I mean, at the beginning, that's a really difficult question, and I think. I mean, at the beginning, what was it? What brings? What is the perception of concrete? Let's put it that way. We were at the beginning, and as I said, I'm Austrian, and I had a German factory to run. So they came up with all sorts of regulation, you know, blow holes, diameters, and stuff like this. And by doing this, we found out that, you know, this was not the perception architect looked at our product. Also that the tech guys were happy that they have at least, and remember this first SAR project where we came up with a color measurement system which we stick together to differentiate the 9 different gradients of gray. So at the beginning we had the system to measure, but it was something different, you know, where everybody has a perception of a living kind of concrete. And I think we're still one step behind to get to that point that we kind of have this living kind of concrete, because what's now happening is that we were so good in fulfilling this tech spec. Now I've gone back into my factory and said, okay, we want now the reverse. We want this cloudiness, and we call this project Vintage. And my head guy at the laboratory, he just went nuts. You know, he really had to take off his afternoon because he was so proud of the concrete that being so persistent. And now I'm turning it back to another level. So I really don't know. I think there is a beauty and a nature of concrete which is hard to catch, and I'm really going after Dow Under for many years, and now we are close to a project, because I always like these metaphors about concrete, you know, the perception of the livingness and so on. But it's still, I think, you know, it is hard to say, but I think we're not good in that way that we fulfill it, because there's so many variances in the living of concrete. I don't know whether this makes sense, but so, yeah.
You got invited also as a part of our studio, where we are going to try to invent a house, a shelter for mountaineers very high in the mountains in very extreme climate conditions. And basically the idea is how to make an object that will heat itself without any energy source in winter, or maybe even cool in summer. How far actually are you with the research, with your products? When do you think actually it will be possible to make a house that will contain use any energy, any electricity, and that the skin will work in this level? How far are you with that?
I mean, I think we're quite far, and as I said before, if you look like Hassan Fatih, a famous Egyptian professor, in the late 40s, he analyzed the African settlements, and they were already on natural air conditioning and stuff like this. So I think what we're doing is that we're bringing back old wisdom in our product, and with nowadays technologies to combine it. And how far we are, I mean, the COP value of 1 to 13 speaks for itself. I think we have one of my guys who look after my little farm. He was one of the energy volunteers, or at least I made him, or I left him no options. Either he gets my heating system or he's out. And so, but he's running and heating his house in an Austrian environment where we have quite harsh winters on 200 euros a year. And I mean, it's 200 euros even too much to spend, but I think we're quite good at that. And even in the 50s, they had already houses with that low energy consumption. I think the biggest problem was that we went to the all glass buildings, and this created so much problems in the design world. Thanks God that I'm a concrete guy, I have now a cure for all of that.
Okay, maybe this is also a little personal inquiry, because as we know, we are all architects more or less obsessed with the concrete, and obsessed in this kind of a rough way of concrete. Also, my, let's say, personal inquiry, because we are dealing with several projects, we all also know what is the problem with the concrete, also when I'm producing it with the casting, and when I'm comparing and we are talking about cladding, we still have our concrete or cladding. So this my personal inquiry with what kind of joint venture would be about this precast work, this beautiful concrete with your product, that it could be some kind of joint venture in this direction, that we would come to something structural and also kind of this roughness of concrete we all so love so much.
Mhm. So the question is how we get together. So I mean,
Yeah, that we still what we have a feeling of this cladding,
Yeah.
even if we are believe it or let's say wish it or not.
yeah.
So that I would, because we also have this investigation, if it cannot be a rough, this kind of strong concrete, what can be some sort of, let's join which would connect this kind of, you know, this work, this kind of casting with this refined structural cladding, you know, which you are producing.
Mhm. Yeah, I think, as the word says, collaboration means that we talk to each other. And what I tell many of my sales guys when they say, "Have you been to that office?" He says, "Yes." "What have you done?" He showed up to the reception and brought the catalog, and then he made his way out. So there was never any talks, and especially in Austria, like we an old empire. So in Vienna, you have to go there to the big names, and they even let me in, and so there was never any exchange. I think one of the things I admire in the American society and in North America is that there is now this ivory towers kind of thinking in academia, and if there is a collaboration between the manufacturers, between the architects, and as I said at the beginning, that at this intersection there will be the new kinds of innovation, because you need to talk to a person, as you expressed now, your wish, what you're aiming for is, and this is so important for me, then I can understand and can go back to my kitchen and say, let's do a schnitzel instead of the spaghetti only. So I think this is for me so vital, so that's why I always go into architect's office and really listen and step back and look at the magazine, not out of a manufacturer perspective, so more like, where is the whole thing heading, and this is the greatest source of inspiration.
Can I add something? I think that you can, yes, because it's the recording, I have to be relatively close. I think that catalogs are important because people take the catalog and it goes away. So I would suggest you to include some explanation, maybe by Matthias.
Mm-hmm.
Very simple. But I think that when the catalogs give you like clues to understand the product, then the openness comes from the architect immediately. I think that there are very basic physical principles that your product is based in and can be explained in, let's say, 1 or 2 pages with some diagrams, and it can be very useful. It's stupid, but it's important, I think. And the other thing is that it's not a critic, but I just want to put on the table that you have all the ingredients. Now, I think many of the ingredients we are trying to deal with in this school, and I'm sure that in other schools, about form, matter, energy, active insulation, but you haven't put all of them together. So you are working with geometry in very, let's say, iconic or formalist ways with Saha, and you are dealing with the active insulation in flat, vertical or horizontal panels. And I think that using geometry to increase the performativity of these panels would give you a kind of much more integrated, let's say, way to understand all these issues that you are dealing. You're reaching. I don't know if it's a comment or you can, or you have these experiments and you are hidden them.
Yeah.
I see many possibilities there, and that's where my question was leading towards, about the use of many different materials.
Mm-hmm.
Whereas potentially I can see you manage to combine several structural performative aspects and thermal performative aspects by taking material away in the right places with the right voids at the right scale, overall form, which I can see, which I found very interesting personally.
Which, coming back to my initial slide, the guy Ulrich Rütter, where we sponsored his work, so he was rare, so he had no steel because all gone into weapons at that time in Eastern Germany. So he had some fibers. So that's why he came up with these beautiful structures back in the 50s. You know, so I think and transferring this into our times, I think I see the whole crisis also as a chance. You know, that we thinking differently and that we have limited resources, and this steers that people think more and doing better in their ambitions in many trades.
We can open to the audience. Questions, comments, critics?
No critics, come on.
Max.
But it would be possible to do just one structure, just one that would be like external cladding, internal cladding. It would contain this performance of receiving the energy and cooling or heating the interior, and it would be also structured in the same way. I mean, would that be possible to do out of your material? If we
That's the whole dream, but I think it needs some good thinking behind them. I think why not? I mean, look at nature. There's so many organisms there who work like this.
If you have a big block like this, and then if you imagine that these are, instead of being plastic, they're open channels. So you have open channels on the internal surface and the external surface towards there. So you have two active loops where you pass through air or water. And in the middle, you have voids which can act as air pockets, as insulation. And then you can straddle and switch between the two. That's the kind of, so it becomes one massive element, but you can switch between it being an insulation or a heat exchanger working both sides, or one side or the other. This is where I think he was leading.
And something interesting is, that we have concrete, we have reinforcement, and now we're doing this plastic pipes. What we're thinking at present is that we print our own piping, and that they're at the same time our reinforcement.
Yeah.
And this is what I learned from North Sales, because we were at the SIAC talk, and I was at his works, and I see when they're doing the large sales for the Americans Cup, and they print kind of the reinforcement. So why we can't do this here? And it's so much more efficient, and with all the tools. And if I see it, your printers and your maker bots here. I mean, this is I think it is so nice that you print out the reinforcement according to the specific need of the panels, and it's then little tubes, and then we rinse through a liquid. So
These are the kind of things that form geometry matter. Put together. Processes of fabrication.
Yeah. So this would be a really cool thing to do together.
Max.
Okay. Thank you for the amazing presentation. It would be amazing if more manufacturers were as open-minded to collaboration and innovation as you guys. Great work. I kind of want to build on Inyaki's statements a little bit, and actually you guys are starting to get into that conversation, but in order to connect this more to studio work, I was curious if you could speak to collaborations that you've had in the past where more than just innovation, where often architects are looking for lighter, longer span, less seams, more energy efficient materials to kind of do whatever it is that we want to do. But how your work and your innovation can help us think more conceptually about formal innovations. And I think there's some experiments about shapeliness and sort of structural performance. So rather than having students sort of just specify efficient materials in our projects, how can this kind of material innovation actually connect back to the conceptual and conceptual formal designs earlier in the project?
It's a tough one. I'll sit down to you.
He's a tough guy.
I think that's more responsibility for our pedagogy, to be honest, really, about being able to break
This is
down
a
how the performance of something like this can be broken down and not thought as a material, but a technology, and how different things can be swapped in for different circumstances.
I give you two examples. One was South Africa, a really you know, when we got the stadium, which is really iconic, like we had 2 years before, we had the European Championship in Austria, and I've not given any single little job there. You know? I remember talking to a GC, and he said, Bryce, I said, you know, in Austria usually we greet people when we open a conversation, even on the phone. He said, Bryce. So the third one I hung up because, you know, what to do. And the other thing was, you know, when I went into South Africa and we were in this huge room and I was texting my mom that I'm safe every hour or so, just this perception of South Africa, you know, in Europe or in Austria it is. And when we then sat down and they put all the weapons, which they really did, on the table, we were talking. And this is, I think you're probably aware of this or not. There's in Western Austria, there's in Vorarlberg, there's this Baukünstler movement. It's a very interesting thing. And I had my house is also built by an architect there. And what I found very interesting, that the craftsman, the carpenter, the architect, you know, the masonry sit together over a beer at night and talk. And I think, as you said, this conceptual thing, if we don't bring it back, because sometimes I'd be banned, or even last time I was excluded from a bid because I did the mock-up in advance on my costs. And I said, what? So if I do a mock-up thinking for the client, thinking ahead before it gets backed, and yes, I'd be aiming for getting the job, but I think on fair means. So I will be then excluded for doing the job. This is kind of, you know, the thinking which I think this is gone so commercialized, and I think there bringing a bit back, bouncing back the ball to you guys, is the architect, the developer took everything out of the hands of the architect. If you look back in the medieval ages, the architect was the focus point. Now it's the guy, you know, make me a nice facade or make it good looking. So I'd be the one. So I think I've been a bit cynic on that, but I think the thing is that it is a value that we talk at the early stage. I fully agree. It has to happen at the conceptual stage, and then where we develop and do things, because then you can steer it in a total different direction. If you just being spec'd and then this value engineering comes into place, you know, then I think at the end of the day everybody is not happy with that. So I think we should do a value engineering at the very early stage. So
it was not easy to respond. Any other question? Eric?
How did you know to buy the French company? Like, what made you say this is going to be a good investment? The technology that you're using now.
So the core technology, what I was saying at the beginning, it was Saint-Gobain, and yeah, and before it was the Germans. Obviously, they're spending so much years into this, and then I Googled it, so I'm kind of a Google thing, and it says, you know, company for sale. So I went there, and so there's lots of tears and convincing. And this is again, my father said, now we're selling real concrete, not this crappy fiber thing there. And we went into the total wrong direction. So I always say, you know, it kept sharpen my arguments. And I think this is also a good thing, that you prove your case and that you come back and I just turned the panels. They have really little hand samples, and it had a glossy surface, which I still try to bring alive, because when I show it, everybody is so keen on having this glossy thing, but there's certain issues which we haven't overcome so far, and we'll bring that out because it's really lovely. So I was falling in love, and yeah, it might be a really child of gold, if you want.
Can you see how many people is working in your office?
Yeah, at present 40. Yeah, and I will reduce it to 10 in the factory, because we want to go full on robots. That's basically my plan. at the moment, and to create better jobs that the other 30 not been laid off, but they're doing better jobs because we want to automate, and we are heavily into this Internet of Things. So that's why I was at the MIT, and I have a couple of other meetings here because I think it's quite interesting to see that, you know, if this is also one of my standing idea, which I didn't mention, is that 3D printing, you know. I think if 3D printing, if you put it to the extreme, that everybody of you have a concrete factory like mine at home, I wouldn't say that this is a good idea. So rather you send me all your files and I FedEx you my panels or something like this, and we share a bit on the profit. And this could be really something, you know, where we could take this to the next level, especially if we talk about mass customization, you know, this all that kind of, when I approach architects and they ask me, is this feasible? I usually say no. Then you look at the reaction and I say yes, but no. And it is, I want to simply get rid of this, asking this question. I just want to make my company as open source that you find out that even push my product to the next stage with all the tools that are already in place. You know, it's just a matter of that we finding that. So for example, we have the cutoffs, and my son is into this computing, and he's now preparing an app that you can make your loved ones, you know, Hannah, or to carve out the names, and this will be sent then to my printer and from my offcuts, and then I can FedEx your heart with your loved Hannah, you know, and you have it then. And so I get a better yield on the product, so I can pass it on to you, and it is a nice way, you know, to get use of the thing. So I think there's a lot of power into that, and that's why I'd be, in a way, this espionage thing, I'd be so happy, you know, because in a way it made me think that there are few bad guys out, but leave them aside. I mean, if I open up my know-how and if I can use all your brains, you know, this will further evolve my doings to the next level. So the whole open source idea, I think it's like Len Koolhaas, you know, also playing around with this architectural is so powerful, because this last one is I have a business consultant background, and the one thing we've been told over and over, contribute to the knowledge exchange. So we had to, you know, best practice, we had to immediately plug it in. If I have really a couple of offices, and I don't blame Saar because they're bringing in lots of new people every time, but there's certain practices in Austria. We have best friends, and there are 10 people, and every 3 months people call me. So they found out about my panels, and these are so cool panels. Why don't I come by and introduce or make a lunch and learn? Then I say, I'll be a good friend, and your partner built my house, but I come anyway to introduce. So I think this knowledge exchange, I think this is a major issue amongst the architecture community. You know, this best practice. I think this will be a powerful weapon, especially when we're talking about conceptual, to really push back, you know, and say to the guys in the black suits that, you know, they may save a little on that one, but in the long run, this is no good.
Yeah.
So
This is where we are promoting this kind of
yeah.
meetings and
Yeah.
inviting people like you. More questions? Last question? Last comments from the table? Okay, please.
Question of durability of concrete. It seems to me that we don't, something's been lost in something like the Pantheon in Rome, which is 2,000 years old,
Yeah.
and still apparently doing beautifully. Have we lost something in the way we make concrete these days?
I don't know. I mean, I'll be always facing this question, you know, warranties. So if you go to the Middle East, they say they want 100 years. And I said, so 100 years? What are you going to do with 100 years? Oh, we insist on 100 years. So I'm going to sign them that in 100 years I'd be warrant that I warrant what I warrant today in a warrant with my lawyer made up this sentence, so I read it through and I don't understand, but they are happy if I present 100 years warrant. So what I'm saying there is the other thing is that facades, there is be a study executed in Europe that the facade will be taken down every 20 years on average, because the visual, kind of looks ugly, so we take it down. So I can't say that we lost certain things, but I think the way how our society evolved is that we have this temporarily short living, that the function sometimes it's there and then it's gone away. So it is a bad thing, I agree, and I think that the concrete lasts. Also, you may argue in my case about the glass fibers, there is a debate, 60 years then the glass fiber is gone. But there are other studies saying that it will last 100 or 200 years. We're probably not coming up to the Dantian, but I think the question is rather, do we need it? If there is the facades taken down in 20 years, I think the much more relevant question is what we do after with the material. How we can process this into the whole chain, and for example, I'd be already preparing or giving out a warrant that if you don't use your facade anymore, I take it back. So why not? And you get a discount on your new with 10%, so bring your facade. Because I think it would steer that thing, that on the one hand we have only a very limited lifetime span of facades, and then people demanding 100, 200 years of warrants.
But at the same time, we're asking much less of our concrete with the facade.
Yeah.
It's just providing the outer shell.
Yeah.
Pantheon is doing everything.
Yeah.
And that's something very different as well.
Yeah. And shells,
Very different.
why shells are not built anymore? Because it's so labor intense.
Yeah.
But as we said before, there's so many smarter ways now with flexible molding that we could bring it back possibly. And that we, as Bella said, that we integrate the insulation into it. And I think, but it needs a lot of smart designers, not the concrete mixer like me doing that.
I think that is enough.
Yeah.
We are in time. So thank you very much.